Hello everyone. Today, we're going to learn about collecting highway subgrade design data and interpreting the subgrade structure diagram design drawings. With its vast territory, China has significant variations in climate, topography, geomorphology, and hydrogeology, all of which are closely related to highway construction. Therefore, based on the principles of similarity in road engineering features, regional differences in surface climate, and the combined and dominant roles of natural climate factors, China's highway regions have been divided into three levels: first-level zoning, second-level zoning, and third-level zoning. First-level zoning primarily serves the overall planning and design of national highways. Second-level zoning mainly provides comprehensive geographic and climate bases and relevant parameters for the design, construction, and maintenance of local highway subgrades and pavements. Designers can determine which second-level zoning their designed highway falls into by consulting the Highway Natural Zoning Map, and then obtain the main pavement disease forms, key issues to address, and relevant design parameters through table lookup. This table presents the issues that need to be focused on in the subgrade pavement design process within each natural zoning, and you can check which issues need to be addressed in your area's subgrade pavement design. Next, let's learn about the dry and wet types of subgrade. The dry and wet type of subgrade indicates the moisture content of the subgrade soil during operation. It directly affects the strength and stability of the subgrade and significantly impacts pavement structure design. Based on its dry and wet state, subgrades are classified into four types: dry, moderately wet, moist, and overly wet. To ensure the stability of the subgrade pavement structure, the subgrade is generally required to be in a dry or moderately wet state. There are two main methods for dividing subgrade dry and wet types, based on average consistency and critical height. The consistency of subgrade soil omega C is the ratio of the distance between the soil's liquid limit water content, omega L, and the soil's water content, omega, to the difference between the liquid limit water content, omega L, and the plastic limit water content, omega P. The dry and wet types of the subgrade can be determined using the average consistency of omega C and the boundary consistencies of omega C1, omega C2, and omega C3. For existing subgrades or excavation subgrades, the dry and wet conditions can be assessed using the average consistency omega C at a depth of 0.8 meters below the roadbed surface in the least favorable season. When the average consistency omega C is greater than or equal to omega C1, the subgrade is in a dry state. When omega C1 is greater than omega C is greater than or equal to omega C2, it's in a moderately wet state. When omega C2 is greater than omega C is greater than or equal to omega C3, it's in a moist state. When omega C is less than omega C3, the subgrade is in an overly wet state. Overly wet subgrades must be treated before paving can occur. For new highways not yet completed, the dry and wet type of subgrade is determined by the critical height method. The critical height of the subgrade refers to the minimum height from the roadbed surface to the standing water level or groundwater level during the most unfavorable season when the subgrade is dry, moderately wet, or moist. The critical height of the subgrade can be determined based on soil quality and climate conditions according to local experience. And if there's a lack of actual data, it can be selected by consulting the relevant appendices. That's all for today's class. Thank you.